I think I know a number of you, but for those of you who don't know me, I'm Solly Ross. I'm one of the lead maintainers of KubeBuilder and a software engineer on GKE. And my mission is to make writing Kubernetes extensions and hopefully also built-in Kubernetes types easier, less arcane. All right, so who here has added an API version or an API to Kubernetes or made a change to an existing API version? All right, so for those of you who haven't, I put together a quick list based on my own personal experiences and the current documentation, and let's take a look at it quickly. So as you can see, there's a lot of steps here. I'm not going to go over all of them, but there's a bunch of different things to do, and most of it involves changing lots of manual Go changes in addition to your API, changing lots of build scripts, et cetera. So what are some of the problems here? Well, there's a really long API review latency, or change-making latency, because you have to make your changes, you have to run all your build scripts, you have to wait for stuff to compile. It's really hard to get that quick feedback. It's also hard to test out your API changes on different versions of Kubernetes, to send it to people. You can't decouple it from Kubernetes versions because it's built into the source code. And then there's also this problem of not having any declarative information attached to your API. So when we write validation and defaulting for built-in types, we do that as Go code. And this is incredibly flexible. It lets us basically do arbitrary logic in validation and defaulting. Sometimes this lets us do really bad things that we later regret in validation and defaulting, but it's very flexible. Unfortunately, this doesn't translate to our OpenAPI specification. And this might seem fine to us as developers of Kubernetes, but it's not great for our users, because users, it turns out, like using fancy tooling that reads the OpenAPI spec. They like doing stuff like having client-side validation. They like having IDEs that provide type hinting. And they like having auto-generated user interfaces that have nice layouts for their types. And with all this manually written Go code, all they see in our OpenAPI spec is like optional and the raw type, like integer or string. And this is like okay for IDEs and forms, but it's not the greatest. And we can do a lot better. We can do a lot better. So what's the solution? So I think the solution is CRDs. Building a API with a CRD is a lot fewer steps. So you have some Go types. You add some special comments that indicate stuff like validation and defaulting. You generate some clients if you need generated clients. This is common for built-in API types. And then you test out your CRD. You generate your YAML from the Go types, and you test out your CRD. So what does this bring us? It brings us a lot faster iteration time. Basically, the only compilation here is compiling our Go types into CRD YAML. And this is really pretty fast. We're only dealing with like one set of types. So it's in the order of magnitude of I can run this on editor save, right? Like same as Go format, maybe a little bit longer. So this also lets us install quickly, test out changes because we don't have to recompile the Kubernetes API server. It lets us, if we want to, decouple changes from Kubernetes releases. We can release with Kubernetes, but we can also say, oh, hey, I want to try this on a newer version of Kubernetes or an older version of Kubernetes. I want to release updates to this type in between and such. As discussed, it gives us a declarative information. All of our CRD tooling, almost all of it, all the cool stuff we can do, is built on top of built-in primitives in OpenAPI or Kubernetes-specific vendor extensions, but it means all that information is there. If the user's tooling can read OpenAPI validation, it can see suddenly that this field that's an integer has a minimum of 0. Or this field that's a string that's not just a string, that's actually an enum that can have, say, failure policy, ignore or fail, right? Like, now that information is there, and instead of just showing a string, the UI could hypothetically show a drop-down, which is a lot better experience for our users. And then finally, from a kind of project selfish perspective, as someone who helps out with some of this tooling, and on behalf of the people who write these extension mechanisms, as a project, we should be dog-fooding our own tooling. If we can't build Kubernetes on top of Kubernetes, how do we expect our users to build good extension experiences, right? Like, we should be able to use what we build to build new features, and that will ensure that our users can also at least have a minimum base. We can build Kubernetes with it, so you should be able to build something cool too. All right. So some of you might be thinking by now, those of you more familiar with CRDs might be thinking, I do not want to write OpenAPI by hand. This is a miserable experience. I have done it. It's not great. You get to write raw JSON or YAML, and it's highly nested and really not great. So the good thing here is we have tooling inside the Kubernetes project that means that you don't have to write OpenAPI by hand. It's a project called Controller Tools. It's part of the KubeBuilder subproject of SIG API machinery, and it lets us write basically Go IDL, for lack of a better term, similar to what you do for the built-in types, but we get to add these additional comments, like if you've ever been in the built-in Go types and you've seen / plus optional, right? We get to add stuff like that that lets us add more flexible stuff that gets translated into the OpenAPI. So let's talk about some of the things that CRDs can do, and where we're good with CRDs and we've reached parity with built-in APIs, and maybe where you might fall back into it, fall back to a built-in API. So let's talk about validation and defaulting. So we actually have pretty robust validation and defaulting from OpenAPI specs. OpenAPI's validation is pretty flexible. It lets us write everything from basic type information to things like minimum, maximum, even regular expression, and this special value called format, which lets us express kind of built-in primitives for validation, things that the API server knows how to validate, but we have a hard time expressing declaratively. So maybe like date time, right? Like it's pretty complicated to validate like a string as a proper date time. So we say this is a date time, and then the API server knows how to validate it. If you need really complex, say, cross-field validation, we can also fall back to validating webhooks. These let us execute arbitrary Go code to do validation, but they do so out of process, right? So we run a pod on the cluster, or we run a process alongside the API server, and we register something that says, whenever a request comes in for this, go out and call this code. And so that mirrors what we have for built-in API types. That's basically the equivalent of built-in API types validation. So if we need something beyond what OpenAPI can provide, we can fall back to that. So here's my first call to action of the presentation, though. There are some primitives that should be possible to validate from OpenAPI, hypothetically, but are really hard, it turns out. Properly validating IP addresses for IPv4 versus IPv6, DNS names, et cetera, may be possible using a regular expression. Really annoying, kind of gets gnarly, you don't want to write it out. But the thing about these is we find them all over Kubernetes and kind of all over distributed systems, right? Like what part of Kubernetes doesn't talk about DNS names? It's all over. All of our names are DNS, et cetera. So we should be providing primitives as the people who build Kubernetes to make this easier. This is something we've run into when adding new Kubernetes APIs and considering whether or not to make them CRDs. So we should start thinking of, can we extend the format field? Can we add additional acceptable formats for fields that are useful to Kubernetes? All right. So immutability and defaulting, getting on to the second half of that. All right, immutability is coming soon. Right now, that's one spot where you might need to fall back to a built-in API, but it should be coming around 118-ish. There's a cap. You can follow it. There's a link in the slides, which I will show you the URL for afterwards. Defaulting, our defaulting is pretty powerful. In OpenAPI, we can specify arbitrary type hierarchies, including like slices and objects. So you can see here, I've got an example that just adds, should be able to see. Have I skipped ahead a slide? No, I'm good. Okay, cool. We've got an example that has an object that has a subfield that's defaulted, and we've just specified it there. We can also specify complex behavior around merging. So if we need to say like this list is actually a map, which is a common thing we do in Kubernetes, we can do that too. All right. So conversion. We can do conversion in CRDs now. That used to be a thing that required a built-in API, but now we have conversion webhooks. They basically look very similar to what I talked about with validation webhooks. You say, call out to this Go code. It will do some conversion between different versions. And then we can mark a certain version as the storage version, just like in built-in APIs. And that's the version that gets persisted to etcd. This is just an example you can see of what the configuration looks like. It's not too hard to write, and it's not too different from what you'd expect from a built-in API. All right. Cross-field defaulting. Just don't do it. It's not worth it. Don't try. All right. So let's talk about some of the things where like maybe we might start getting into shaky ground in terms of like CRDs versus built-in APIs. So the first is embedding a built-in API type into a CRD. Now, this is possible with some caveats, right? As previously mentioned at the beginning of the presentation, remember I was like, we don't have declarative validation information on our built-in types. Well, that comes back to bite us when we go to embed stuff into CRDs. So a really, really common case for both our users and for us is embedding pod spec into types. So think about this as like the stereotypical like deployment replication controller case where we want to say this thing creates pods. So you get the basic validation, but you don't get any of the more complex stuff like this field is an enum. And sometimes this is acceptable, but a lot of times you want to warn your user ahead of time. And so for this, you either need to fall back to a built-in API, you need to use a validating webhook that calls out to like, does a dry run against the API server or some such. Now, this is like another case where we could make this experience a lot better. And there's a few different ways we could do it. We could add references in our open API schema. So you could just say, hey, API server, this entire tree is just a pod spec. Use your built-in definition of pod spec. We could add declarative validation to all of our built-in types, which is really nice for users for the aforementioned reasons and also solves this issue. There's a few different ways. This is something else we need to work on. All right. So, so Subresources. Sorry about this. I can't actually see the slides on my computer. All right, so Subresources. Well, we have scale and status support. That's a lot of what you need. You can specify a spec path, for instance, for scale, spec, and status, and you get /scale. For arbitrary subresources, well, first of all, make sure you get through API review and they say it's OK to add a new subresource, because like, chances are you might not need it. But if you do, you're going to have to go back to a built-in API. Now, we've seen this request on occasion, but it's not clear how often it comes up. We may need to eventually add this to CRDs, but it might turn out that we don't need sub-resources, new sub-resources as much as we think we do. There's not a ton of them in Kubernetes. Most of them are kind of weird ones, like all of the ones like logs, and for instance, and most of the rest are stuff like scale and status. All right. So here's another one where we actually need to fall back to a built-in API, high read-write performance. So this came up recently in the review for a type called endpoint slice, which is a KEP about reworking the way endpoints work in Kubernetes. If you need to read and write a lot of objects real quickly, you're probably going to need a built-in API because we don't have protobuf support. And it turns out, for those of you who are not familiar, encoding and decoding JSON in Go is really slow, like really, really slow compared to other stuff. So this is fine for a lot of types, especially stuff like deployment, where you've got a bunch of kind of big-ish objects that don't get updated a ton. But for stuff like endpoints, where you're writing all the time and writing health checks and stuff like that, you're going to encounter some issues. We could add proto support to CRDs. This is kind of a, we'd like to do it eventually, and less of it's coming in 1.18. But we're going to need to eventually get there. All right, field selectors. Hint, you probably don't actually need field selectors unless you are pod, and it is the future, and everything is a CRD, which would be a glorious future indeed, and everyone drives hover cars. All right. So the last kind of set of things are kind of the Bootstrap problems, okay? So if your types need to be present for the API server to boot, you might need to fall back to a built-in API. We currently are a little bit sketchy on how to deal with the Bootstrap problem for CRDs. It might be possible to work around it. If you have any brilliant ideas for how to solve it, come talk to us. We'd love to get people involved in that. Kind of similarly, if they're needed to be installed in cluster boot in order for, say, the node to start pods, which is another problem that has come up in the past, you may need to fall back to a built-in API. This is a problem kind of that has been encountered by a couple of storage and Signode related projects where they eventually moved to built-in APIs for this reason. We'd like to solve this one eventually as well and have kind of a canonical path for this to support this kind of thing, but it's not quite there yet. All right. So I've talked a lot about, oh, sorry.
Yeah, the last slide.
Sure.
Can you give examples of a Bootstrap problem that has been solved? Like this?
So some of it is solved. The main cases that I know have been solved by the alpha versions were CRDs, and then when we moved to beta, we moved to a built-in API because we weren't quite sure how our users were going to deal with it. So just about your comment was like really good timing because I'm just about to talk about it. Yeah, so the two major cases of this that I know of were related to storage and pod. There's last two there. And they were mostly around, as far as I know, like users expect these things to be present on the cluster when they start, like runtime class. They like, oh, I need to start pods with my runtime class. It needs to be there. Like maybe I'm expecting to run a pod in order to run a webhook to support runtime class, because I think that was before some of the declarative validation and defaulting was as robust as it is now. And so like there was kind of a chicken and egg problem there, and they solved it by when they moved to beta, they moved to a built-in API. So they still got some of the nice benefits that I talked about around rapid iteration from during their alpha phase, which is cool, and that's a path you can take even if you anticipate you're going to have this Bootstrap problem. But it would be awesome to solve this eventually. I think it's kind of been sitting in some of the SIG cluster lifecycle discussions. There hasn't been a pressing use case since these two moved that I know of, but they've, I think, been thinking of it on and off, and we've had some proposals in the past. I've wrote a little bit about it. But if you're interested in taking up and championing this work, definitely talk to SIG Cluster Lifecycle, and you can also talk to me as well. But there are cases that have used this successfully that didn't have Bootstrap problems. So the volume snapshot controller is currently using this. That's in the Kubernetes CSI org. And if you go on the volume snapshot page on the Kubernetes docs, it's like, this is a CRD type. You need to install it, and then you can use it. Cluster API is using this. All of Cluster API is built on top of this. And then there's a few other projects. But these are the kind of prominent ones, and provided, I thought, 2 good examples of ones that are using it now and 2 good examples of ones that had the Bootstrap problem. All right. So if you happen to fall asleep during any of this and just woke up, in summary, CRDs provide fast iteration time, nice declarative features for users. They're also important. It's also important to dog food our own stuff. But we still have some problems, especially around some of the advanced corner cases. But the key takeaway, I think, this is when I was looking at this, all of these problems are solvable. It's not like, none of these are like fundamentally like, we need to re-architect Kubernetes entirely to solve this problem, right? Like, it's all things that we can solve. And we should, because if we're hitting these, our users are going to. All right. Any questions? How am I doing at time?
Question. I sort of wanted a question about the sub-resources.
Oh, yeah,
I don't know if
feel
maybe
free.
we should take it offline.
Well, I mean, if you have a question, we can take it offline if it goes too long, but feel free to ask right now.
Yeah, so 2 well-known sub-resources other than scale, like exec and logs, right? And so for example, in the context of Cluster API, having something like logs for a machine object could be useful. I'm not saying that necessarily so, but I can imagine a use case there. And maybe other sort of sub-resources that maybe we haven't even thought of. And one way, or maybe even to implement logs and exec in a different way, right? And one way maybe to support that is to have, redirect the request to a different service where, the API server is then just responsible for, receiving the requests and matching the sub-resource with some kind of, some logic that generates another URL, right? And what, are there discussions around this? Do other people see a need for this? What do you think as far as like the possibilities?
I've seen some discussion around it before. I think this is mainly from what I've seen a case of like cost benefit analysis and doing like the common low hanging fruit first. I have seen people asking for stuff like custom logs before. Logs, like you said, logs are kind of one of the weird sub-resources. So like, quick summary, sub-resources in Kubernetes usually fall into 2 categories. Projections, which take data in a base resource and transform them. So this is things like scale and status, and I think like there's a binding sub-resource at one point that did weird things. And then there's stream sub-resources, which do 1 or 2 directional streaming. So this is things like logs, exec, attach, where you're actually like not acting like a normal CRUD resource in Kubernetes. And so the things like that aren't projections are kind of like funky to handle, and there's only been a few calls for them that I know of. And so I think it's just mainly been like, there's like more pressing things to work with. That being said, talk to SIG API machinery. If you have ideas, talk to them first, put together a design. Yeah.
Okay, so like kept wanted.
Yeah, talk to them first,
Got it,
though.
yeah.
But like, most of these things are like, we can solve them. We just have to, we need to put in the effort, and we need to make sure we're designing a solution that isn't going to cause us trouble in the future.
Thanks.
All right, thank you, Solly.
Yep, no problem.